The Cassini spacecraft has shown us that there is literally hundreds of lakes scattered throughout Titan's north and south polar region. And we think that these different lakes have a variety of different hydrocarbon mixtures, making for a very complex system to try and understand how Titan works.
So here things overlap quite a bit,
Right.
and this region here is sort of loosely defined as an amalgam of different CH bending and stretching and combination modes.
Lakes with different mixtures of molecules will evaporate and freeze differently. That's because different molecules have different temperatures and pressures where they exist as solids, liquids, and gases. One of the things that we wanted to understand is if by landing in a lake there would be any potential hazards on splashdown. And one of the possibilities that there might be frozen icebergs floating around on a Titan lake.
So you can see that all these lakes are all contained within here. So any liquid that falls in here gets trapped in here, and then it either goes down or it evaporates back out.
Ligeia Mare is Titan's second largest sea and the one that the Cassini spacecraft has imaged the most. In an image acquired in July of 2013, we were surprised by a 10-kilometer sized object that just appeared in the middle of the sea where nothing had been there before. We've affectionately called this feature Titan's Magic Island, and our four best claims for what might be causing this are wind that's kicking up waves on the surface of the liquid, floating debris, bubbles, or perhaps methane or ethane ice that acts like icebergs here on Earth.
To find out if Titan's Magic Island could have been an iceberg, we experimented with different mixtures of hydrocarbons in the lab, realizing that different mixtures of hydrocarbons will have different melting and freezing points. It turns out that methane will absorb nitrogen from Titan's atmosphere, and the nitrogen changes the freezing point of the mixture. The freezing point of nitrogen and methane is at very low temperatures, much lower than any temperature we've ever observed on Titan. This means that methane icebergs won't exist on Titan, at least not at the temperatures that we've observed so far on Titan.
Here at Cornell, we analyze spacecraft data and try to understand what we're seeing. But in order to understand what we're seeing in the data, we need laboratory experiments that Mike performs in order to understand what might happen on the surface of Titan. And by merging the results of the laboratory experiments with what the spacecraft data is showing us, we can come up with a hypothesis or claim for what is actually going on Titan and learn more about how both Titan and Earth work.